Hi friends, welcome to my channel. This is Suresh. In this session, we will discuss about resistance and Ohm's law and how to calculate the resistance based on design parameters and how to calculate the value of resistance based on operating conditions and what are the ranges of resistances, what is meant by short circuit and what is meant by open circuit, and then limitations of Ohm's law and what is the difference between potentiometer and rheostat, and then how to calculate the resistance based on color coding and based on alphanumerical data which is present on the body of the resistor. Please watch the video till end of the session, then you will get full confident about the Ohm's law and resistance, and you will be able to solve questions based on these topics. In this session, we will discuss about resistance and Ohm's law. Let's start the session. In general, materials having the property to oppose the flow of charge or flow of current. This ability to oppose or resist the current is known as resistance, and it is represented by a symbol capital R. It may be a small r. Materials are classified into three categories: conductors, semiconductors, and insulators, based on the values of resistances. This resistance of a material can be represented in circuit model by a resistor. So the symbol for the resistor is like this, and it represented its resistance R. The units for the resistance is ohms, and the symbol is like this. How to calculate the value of resistance for a particular material? There are two ways to calculate the value of resistances. First one is by using design parameters, and second one by using operating conditions. First one we will see. Let us consider a conductor whose length is L meters and area cross section of the wire is A meter square, and this material having resistivity is rho. Based on three values, length, area, and resistivity of a material, we can calculate the value of resistance are given by rho into L by A. This resistance can be modeled as like this. This is terminal A and this is terminal B, and its value is represented R ohms, and R is given by rho into L by A. Resistance value here depends on length of the wire and area of cross section of the wire. So from this formula, we can say that if length of the wire is increases, resistance is increases. If length of the wire is decreases, resistance is decreases. But from this formula, we can say that resistivity equal to R into A by A. From this, we cannot conclude that resistivity of a material depends upon the physical dimensions of a material. No, it is wrong. Resistivity of a wire depends upon on which the material is made up of. It does not depend on the physical dimensions. So we can say that resistance is depends upon the physical dimensions and resistivity is depends on the material. Now we will see how to calculate the value of resistance based on operating conditions. For this purpose, we will require Ohm's law. Ohm's law states that the voltage across a resistor is directly proportional to the current flowing through the resistor. This is the resistor whose value is R ohms, and the voltage across the resistor is V volts. This is the volts, and the current flowing through the resistor is I. So from this, the value of voltage, this voltage is proportional to the current flowing through the resistor. Under the condition, temperature is kept constant. Voltage directly proportional to the current. When we remove the proportionality constant, V equal to R into I, where R is the resistance of a material. Resistance. In electromagnetic theory, Ohm's law, J proportional to E, where J is the current density and E is the electric field intensity. Sigma is called conductivity. Then there is a relationship between conductivity and resistivity. Reciprocal of resistivity is known as conductivity. So rho is equal to 1 by sigma. Now substitute the conductivity in terms of resistivity. E equal to rho into J. This is very very important formula. The range of resistances is 0 ohms is the lower limit, infinity ohms is the higher limit. Now we will see what are these significances. In first case, we will see resistance R equal to 0 ohms. Means resistance is nothing but ability to resist the flow of current. Means resistance is 0 means it does not have the capability to resist the flow of current. Means it does not oppose the current. So current flowing through the element is maximum because opposing force is not exist. Thus current is maximum. Let us consider a network. This is the network and its output terminals are A and B. Across the output terminals, I am connecting an element with resistance R equal to 0 ohms. Current flowing through the element equal to I ampere and voltage across the element is 0. Then how we will get 0? As per Ohm's law, V equal to I into R. So when we substitute the value of R in this equation, V equal to I into 0 ohms. So V equal to 0 volts. Means resistance R equal to 0, and this is called as a short circuit. For a short circuit element, the voltage across it is V equal to 0 volts and current flowing through it depends on the network. This the value of I in this network is depends upon the network. It may be any value. It may be 5 amperes, it may be 10 amperes, it may be 20 amperes. It depends upon the network elements and the sources. In second case, R equal to infinity ohms. So this is the network and A and B are the output terminals. Across the output terminals, I am connecting an element with resistance R equal to infinity ohms. So from the Ohm's law, V equal to I into R, I equal to V upon R. When we substitute R equal to infinity, limit R tends to infinity, V by R. So value of R in this equation, you will get I equal to 0 amperes. So R equal to infinity ohms, it is said to be open circuited. For open circuit, the value of current I equal to 0 ampere and voltage across it is maybe any value. This voltage V value, it depends upon the network. From this, we can conclude that R equal to 0 is called as short circuit. R equal to infinity, it is called open circuit. So for short circuit, voltage across the element is 0 and for open circuit, current flowing through the element is 0. For suppose I have one voltage source V, its value is suppose 230 volts. I am switch off this voltage source to 0 volts. At a 0 volts condition, this voltage source is replaced by a simple short circuit. And I have a current source, its value is 25 ampere. I am making it is to 0 amperes. This current source is replaced by open circuit. When current equal to 0 means it is represented as a open circuit. A resistor which obeys Ohm's law is known as linear resistor. For a linear resistor, slope is constant and it is passing through origin. When we look into the curve number 1, the slope of the curve is constant, it does not variable, and it is passing through origin. So first two conditions are satisfied, then it is said to be a linear element. So we can say that a resistor which obeys Ohm's law is known as linear resistor. A resistor which does not obey the Ohm's law, it is said to be a linear resistor. In second figure, this curve shows that the resistor is a non-linear resistor. For a non-linear resistor, here the slope is variable, but curve is passing through origin. Means first condition is not satisfied, and the curve is non-linear. So this resistor is a non-linear resistor. Let us consider three resistors: Ra equal to 100 kilo ohm, Rb equal to 10 kilo ohm, and Rc equal to 1 kilo ohm. For these three resistors, I drawn VI characteristics which are shown in the figure. Curve A represents for a resistor Ra, curve B represents for resistor Rb, curve C represents for resistors Rc. From these three curves, we can conclude that when resistance is increases from R equal to 1 kilo ohm to R equal to 100 kilo ohm, the curve is shifted towards the voltage axis. Suppose when we decrease the resistance from 100 kilo ohm to 1 kilo ohm, the curves are shifted towards current axis. This is for increasing and this is for decrease. When we increase the resistances, the curve is shifted towards voltage axis. When we decrease the resistances, the curve is shifted towards current axis. The reciprocal of resistance is known as conductance and it is denoted by a letter G. So G equal to 1 by R. From Ohm's law, R can be written as V by I. So we'll substitute in this equation. We will get G equal to I by V. Conductance is nothing but it is measure of how well the element will conduct the current. Its units are mho and its symbol is like this. It is inverted ohm symbol. In SI system, the units for the conductance is Siemens. 1 Siemens is equal to 1 mho and it is equal to 1 ampere per volt. We know Ohm's law V equal to I into R. In conductance form, we can written as I equal to G into V. This is the Ohm's law in conductance. Now we will calculate the power dissipated in the resistor. So we know already power P equal to V into I. As per Ohm's law, V equal to IR, then we substitute, we will get I square R and we will substitute the voltage V square by R. When we express the power dissipated by a resistor in terms of conductance, so power P equal to V into I, that is equal to V square into G and that is equal to I square by G. It is in terms of conductance. This is the summarized formulas for voltages and currents and resistances and power. This circle is drawn based on voltage V equal to I into R as per Ohm's law and power P equal to V into I. When we look into the first quadrant, it is responsible for voltage. These three formulas are responsible for the voltage. And when we look into the second quadrant, these three formulas are responsible for the current. And when we look into the third quadrant, these three formulas are responsible for the power. And when we look into the fourth quadrant, and these three formulas are responsible for the resistances. In electromagnetic theory, the amount of power dissipated in a conductor can be written as power P equal to J into E. As per Ohm's law, J can be written as J equal to sigma into E. So power P equal to sigma into E square. From this equation, we can express that power dissipated in a conductor is proportional to the square of the electric field intensity. About discussion, we will observe some points. Even though resistor is a linear element, but the power dissipated in a resistor is a nonlinear function of either voltage or either current because P equal to I square into R or otherwise V square by R. So that's why power dissipated in a resistor is a nonlinear function of voltage or current. Resistance and conductance both are positive values. Then the power dissipated in a resistor is a positive value. So this positive value means power absorbed by the element, means power absorbed by the resistor. So power absorbed means it is a passive element. Resistor is a passive element. So one more important observation is that when a circuit is active, resistance cannot be measured during operating conditions. So when we look into these two figures, these two are active network because 240 volts is present and here 25 volt source is present. So in order to calculate the value of resistance across the terminals A and B, first we have to switch off or isolate the sources. Now we will isolate the sources, then we will calculate the resistance of the remaining circuit. In figure number 2, in this question they are asking resistance across A and B. For this purpose, we have to switch off this voltage source. For switch off voltage source, this voltage value tends to be 0 volts. For 0 volts, this voltage source can be replaced by a short circuit. Then we will calculate the value of resistance. From this, we can conclude that resistance cannot be measured in operating conditions or when the network is active. Resistance can be calculated only when the network is passive. If you want to calculate the value of resistance of a network, then we have to install voltmeter and ammeter in the network. Then only we have to calculate the resistances during the operating conditions. Some limitations are there for applying Ohm's law. Ohm's law is valid only for linear elements and it does not valid for non-linear elements. And non-linear elements means semiconductor devices. It indirectly says that Ohm's law cannot be valid for semiconductor devices because its characteristics are not linear characteristics. When we look into the Ohm's law, V equal to I into R, here the values of V and the value of I, these are static in nature. These values does not vary. So the Ohm's law gives only for the static components. And third point, it may not give desired results when the physical conditions are changed, like temperature and pressure. If these two conditions are vary, we cannot get accurate results during Ohm's law. We are seeing the symbol for the resistance as shown like this. This is a fixed resistor whose value is R ohm, and this is the variable resistor whose value is variable between the limits. This is the range of this variable resistor. So variable resistor is also known as rheostat. This variable resistor has three terminals. When we see, this is the terminal number 1, and this is the terminal number 2, and this is the terminal number 3. If we will use these three terminals in a circuit, it is said to be a potentiometer. Potentiometer nothing but it provides adjustable voltages. Even though we have a fixed voltage source, we will see the diagram of a potentiometer. This is the potentiometer, and the terminals are A, B, and S. These are the three terminals. Across the terminal B and S, we are connecting a lamp, and these two terminals A and B are connected to a voltage source. Here, the value of voltage source is a fixed value. It does not vary. For a potentiometer, we are used three terminals, and here S is the sliding contact. This S is the sliding contact. This position is 0 ohms position, and this position is some X position which is a higher value. When we move the sliding contact between this position and this position, the voltage across the bulb is vary. When it is at position A, voltage across the bulb is maximum because total voltage drop across the bulb. When the sliding contact is at B position, voltage across the bulb is 0 volts. From this, we can say that in potentiometer circuit, we are using three terminals of a variable resistor. Then, what is happened when we use two terminals? A variable resistor in which we are use only two terminals, it is said to be a rheostat. A rheostat and potentiometer, construction-wise, both are similar, and here the terminal P is left open. It is not connected in the circuit. Here A is the fixed terminal and S is the sliding contact. When we vary the sliding contact, value of load resistance changes. This rheostat is also known as dropping resistor. It is used to reduce the voltage across the load, and it is more effective for controlling the current flowing through the load. The function of rheostat is effective when resistance of the rheostat must be greater than the load resistance. Means the value of resistance of a rheostat should be greater than the value of load resistance. Then in this case only the function of rheostat is effective. In day-to-day life, how to calculate the value of resistance by seeing a resistor? There are two ways to calculate the value of resistance. One is based on color coding which are appeared on the resistor, and second thing based on the alpha numericals which are written on the resistor. First we will see color coding. There are two types of color coding methods are there. One is 4-band method and another one is 5-band method. These are the colors list: silver, gold, black, brown, red, orange, yellow, green, blue, violet, gray, white, and for this one we have to assign some values. One is significant figures and other one is multiplier, another one is tolerance. For 4-band fixed resistor means on the resistors we are seeing 4 bands. This is band 1 number 1, and this is band number 2, and this is band number 3, and this is band number 4. That's why it is known as 4-band resistor. So for calculating the value of resistance for this resistor, first two bands, these two bands are gives the significant digits. Means band number 1 gives the first digit. It is brown color. For brown color, the value of significant digit is 1. I have written 1. For second band, it is green color. Green color also it gives significant digit. So for green, the value of significant digit is 5. I have written 5. and the third band, it is the multiplier value. So it is a red color. The value of multiplier for the red color is 10 square. So I am multiplying with 10 square, and last band which gives tolerance means it is plus or minus. It is a blue color band. For blue color band, the value of tolerance is 0.25%. So it is 0.25%. Then it can be written as 1500 ohms plus or minus 0.25% as a tolerance. In this resistor, you can notice that last band, and it is separated by a distance 1.5 to 2 times more than compared to other bands. For a 5 band fixed resistor, in this 5 band fixed resistor, the resistor has 5 bands. This is band number 1, and this is band number 2, band number 3, band number 4, and band number 5. For the 5 band resistor, first 3 digits are give significant digits, and first digit is brown. For brown, the value of significant digit is 1, and for green, the value of significant digit is 5, and for red, the value of significant digit is 2, and it is the multiplier. This is the violet color. So for violet color, the value of multiplier is 10 power 7, and for tolerance, plus or minus, it is a blue color. Tolerance is 0.25%. So it can be written as 1520 mega ohm plus or minus 0.25%. From this, we can say that for a 4 band fixed resistor, the significant digits are 2. For a 5 band fixed resistor, the significant digits are 3. Now we will see another type of model to calculate the value of resistance. When we see resistor, on this resistor there are alphanumerical number is present on the resistor. From this alphanumerical code, how can you get the value of resistance? On the resistor, it is marked as R47. Its value is 0.047. R means it is nothing but a point. So R10 is nothing but 1.0 ohm, and 4R7 means it is 4.7 ohm. 47R means 47 ohm. 100R it is 100 ohm. 1K 1 point kilo ohm means 1 kilo ohm. 10K 10 kilo ohm. 10M 10 mega ohm. And the tolerances are given as F equal to 1%, G equal to 2%, J equal to 5%, K equal to 10%, and M equal to 20%. Let us take one example. This number is present on the body of the resistor. So how can we get its value? 6 K means kilo, this 8 is the point, and F is the plus or minus 1% tolerance. It is 6.8 kilo ohms plus or minus 1% tolerance. We will see another example. Suppose I have taken 68 kilo ohms plus or minus 10%. How can we represent in marked value? So 68 kilo ohms, kilo, and for 10% tolerance, it is nothing but K. 68 kk means 68 kilo ohms and 10% tolerance. If you have any queries about this session, please feel to contact me on my WhatsApp number or my email ID. In the next session, we will see some practice problems and some previous questions which were asked in engineering service examinations and GATE and some other PSU examinations. Thank you for watching this session. If you like the content in this video, please like it and subscribe the channel. And if it is useful to others, then share this video. Thank you.